any point P on the coordinate plane in three-dimensional geometry is always written in the form of triplet with the three values x, y and z. Any point on xy plane is represented as x, y, 0 and the equation of xy plane is y is equal to 0. So the distance formula you have learnt using the two coordinates, that is, it is a square root of x2 minus x1 whole square plus y2 minus y1 whole square. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we'll be taking up the new chapter, three-dimensional geometry. So previously, you have studied the coordinate planes only in x and y axis, that is only two-dimensional. So here, we are extending one more axis, that is x, y, z. So we call it as three-dimensional coordinates. Hence, the chapter name is three-dimensional geometry. So here in this session, we will be discussing on how the three-dimensional geometry, the coordinate planes will be, the distance formula and section formula which you have learnt in two-dimensional. Here we are extending it to three-dimensional. Now let's see what is this coordinate planes. Now here is a point P. So which I have taken in the form of three-dimensional x-axis. All these x, y, z axis are perpendicular to each other. So you can extend this x-axis here also, y-axis this side and z-axis this side. Here I have just taken a part of x, y, z axis. I have mentioned a point on the plane. So any point P on the plane here will be written using the coordinate in the form of x, y, z axis. This point P will be at a distance z and at a distance y and at a distance x from x-axis, y-axis and z-axis respectively. So these distances are mentioned in the form of the coordinates in terms of x, y, z. So therefore, the three planes determined by the pair of axes are called coordinate planes. So here we have three planes, xy plane, yz plane and xz planes. So these planes determined by pairs, two pairs. When you consider one plane, here it is only z-axis and this plane x-axis and y-axis and this plane it is y-axis and z-axis. So all the three planes determined by two axes here are called the coordinate planes. Now here we are supposed to note some important point while studying all these three axes in a coordinate plane. The first point says, the coordinate of a point P in three-dimensional is always written in the form of triplet, that is x, y, z. First, distance from x coordinate. Second, distance from y coordinate. Third, distance from z coordinate. Any point P on the coordinate plane in three-dimensional geometry is always written in the form of triplet with the three values x, y and z. So these are nothing but the distances from the yz, zx and xy planes. Next, the coordinates of the origin is always 0, 0, 0. So here you can see this O represents the origin. So in two-dimensional you would have written it in as 0, 0. One extra axis, z axis is represented, which is also 0. Again, any point P on the x-axis is x, 0, 0. So in two-dimensional we would have write in the form of x, 0 because y value is 0. So therefore on x-axis y value, z value is 0. So therefore the coordinates of any point on the x-axis, suppose I take this y, z axis. If this is at a distance of 1 centimeter, then we write this point A as 1, 0, 0 because the y and z coordinates are 0. Similarly, any point on the y-axis is written in the form of 0, y, 0. Y must be the second coordinate. So therefore, if this is the point P, which is at a distance of 1 centimeter, then we write it as 0, comma, because x-axis is 0, y value is 1, z value is 0. Similarly, any point at a distance 1 on z-axis is 0, comma, 0, comma, z. Here, if it is 1, we write it as 1. So, this is the general form of writing any point on the x-axis, y-axis and z-axis respectively. Now, coming to the plane. So, plane here, so we have 3 planes, x, y, z. So, this complete here is only the xy plane. So, this is the xy plane we can say. Now, if suppose P is a point somewhere here which lies only on the xy plane, then on the xy plane we don't have z values. So, for that purpose, we will write the point in the form of x, y, 0. So, because on xy plane there is no z axis, therefore its value is always 0. So, we write any point on the xy plane in the form of x, y, 0, and the equation of the plane is z is equal to 0 because we have the values for x, y and we don't have the values for z. So, therefore, any point on xy plane is represented as x, y, 0 and the equation of xy plane is y is equal to 0. Next, we will talk for yz plane. This is the yz plane now. So, clearly you can see on yz plane, x do not have the value, it is always 0. It only meets that plane in the point 0. In all other cases also it is 0. So, therefore, any point Q on yz plane, x-axis is 0. So, therefore, we will write only the other two values y and z. And the equation of yz plane will be x is equal to 0. So, therefore, you can observe there. So, equation of yz plane is x is equal to 0. Any point on yz plane will be 0, y, z. Next, we are left with the other plane. So, this is the other plane you have here. So, now we are left with xz plane. Xz plane means the y value is 0, it only meets at origin. So, therefore, on xz plane, any point R can be written as x, 0, z because the y value is 0 on xz plane. So, therefore, and equation will be y is equal to 0. So, you can see equation of zx plane is y is equal to 0 and any point can be written in the triplet form as x, 0, z. So, on the other hand, if you take only the equation of x-axis, only equation of x-axis is y is equal to 0 and z is equal to 0 because both are 0. Equation of y-axis is x is 0, z is 0. Equation of z-axis is x is 0, y is 0. So, these are the things which you have to be remembered. Then, any other point other than lying any of the planes, if it lies in all the 3 lines, if the distances of x, y, z values are defined, it is written in the form of triplets x, y, z. Next here, we have a concept called octants. What do you mean by octants? So, suppose in a 2-dimensional plane, you have learnt about quadrants. So, what do you mean by quadrants? The 2 coordinate planes x, x dash, y, y dash divides the plane into 4 parts. Therefore, they are called as quadrants. When you introduce one more axis here, a z axis, it divides the plane into 8 parts. So, therefore, those 8 parts are called as octants. And the coordinates which you have represented in the form of 2-dimensional place will be plus plus, minus plus, minus minus and plus minus. Like this, you would have written the coordinates of plane and its positive, negative values looking at the positive x-axis and positive y-axis also. So here also we will take plus, 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 minus, minus, minus. So based on that, the octants also have the values which is positive, negative, and the values, that is numerical values, are considered as negative and positive. Let's see how octants have the values in terms of positive and negative. Now I said we have 8 divisions here which are called as octants. And in the first octant, all are positive. In the second octant, only x is negative, other 2 are positive. In the third one, xy are negative and it is positive. Fifth one, plus, plus, minus means xy positive, z negative. Sixth one, x and z are negative, y positive. Seventh one, all are negative. Eighth one is x is plus, y and z are negative. So you should remember these values on which octant the given point lies. They may ask you for 1 mark question. So looking at the coordinates of the octants, you can see whether the point lie in first octant, second octant, third octant or others. Now here we have taken a question, name the octants in which the following points belong to. Okay, so here I have taken the serial numbers, point I have taken. You should mention on which octant the following points lie. So the first one, all are positive. So therefore it belongs to the first octant. Second one, again, all are positive. So therefore it belongs to first octant. The third one, only x is negative. So it will belong to second octant. Next we have -3, 1, -2. X and z are negative, y is positive. It belongs to sixth octant. Next we have 4, -2, 3. So it belongs to fourth octant. Next we have 4, -2, 5. Plus, minus, minus. So we have x positive, other 2 are negative. It belongs to the 8th octant. Next we have 4, 2, -5. So it belongs to the 5th octant. Next we have -4, 2, -5, 6th octant. We have -4, 2, 5, 2nd octant. We have -3, -1, 6, 3rd octant. Next we have -2, -4, -7, all are negative in 7th octant. So this is how we can prefer the points which lies on the given octants. Next we come across a distance formula. So the distance formula you have learnt using the 2 coordinates, that is, it is a square root of x2 minus x1 whole square plus y2 minus y1 whole square. Since we have one extra coordinate in 3-dimensional geometry, the same formula is extended to one extra coordinate. Along with these two, you have plus z2 minus z1 whole square. Let's prove this distance formula now. Now, here I have taken a 3-dimensional axis, x, y and z. I have taken a line PQ. This is the line I have taken, PQ. Now what you should do is draw PM and QN perpendicular to this XY plane. So just write, consider line PQ. This PQ is not parallel to Z axis. Now draw PM and QN perpendicular to XY plane. We know that on XY plane, the coordinate of Z is 0. So therefore, on XY plane, the point M and N will have the coordinates as x1, y1 and here it is x2, y2. Because the z value is 0, we are only considering this 2 planes now. So therefore, the distance Mn here we can write it as in 2-dimensional geometry as x2 minus x1 whole square plus y2 minus y1 whole square. So this is how we can write. Next is I have taken draw PR perpendicular to QN. So draw PR perpendicular to QN. So if you draw this as a perpendicular, you can clearly say the shaded region will be rectangle. So therefore what we can write, MN is nothing but PR. So the distance they are opposite sides of the rectangle, we can write MN is equal to PR. PR and Q is rectangle. So since they are rectangle, we can write MN is equal to PR, whose value is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Next, consider this right angle triangle PQR. So from triangle PQR, so since this is right angle, I am writing the symbol of right angle only. So I can write PQ square is equal to QR square plus PR square. So the QR here is actually nothing but QN minus NR square. So that is QN minus NR square plus PR square. So this NR is nothing but PN. So you can take the coordinate of these two as this as Z2, this is Z2 distance, and this is at the distance Z1. So this is the distance of Z2. So what I can write here is this can be written as Z2 minus Z1 whole square. Now since MN is equal to PR, this implies MN square is equal to PR square. So here previously we have got Mn is equal to square root. If you square both sides, it will be x2 minus x1 whole square plus y2 minus y1 whole square. So therefore Mn square is equal to PR square means PR square can be written as x2 minus x1 whole square plus y2 minus y1 whole square. Now rearrange these terms. Here we have PQ square. So PQ can be written as x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square under the square root. So this is what we have proved. So therefore the distance of the line or the distance of any 2 points can be written in the form of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square under the square root in a 3-dimensional plane. So the next one is section formula. What is section formula? When a line is divided by some point in the ratio m is to n, then we are writing the coordinate of this point. Suppose you have a point A and point B, which is in the form of line AB, and when any point P divides it in the ratio m is to n, then writing the coordinates of point can be found using the section formula that you have learnt previously in 2-dimensional using xy plane. So here again we are extending with one more axis, z axis. Let's see how we can write the section formula in 3-dimensional plane. This question is very important for 5 marks question. So very important question for your examination. Let's see the proof now. So derive the formula if A, B are 2 distinct points in the space and a point P divides the line AB in the ratio m is to n internally. So here I have taken a line AB and I have taken a point P which divides it in the ratio m is to n. So like this a question may be asked in your examination. So now look at the diagram here. So this is the diagram for a section formula which I will explain you now. So I have taken a line PQ instead of AB. So here let's take PQ as line AB and R as the point P which divides the ratio m is to n internally. So instead of AB I am just taking the points in the form of PQ. Let's see now. So let P be the point and Q be one more point whose coordinates are x1, y1, z1, and Q is the point whose coordinates are x2, y2, z2. And let R be the point which divides the line in the ratio m:n. So here I have taken m and n. So and R is the point whose coordinate, let it be x, y, z. Now I have to write the coordinates of R. So let's see now. Draw PL, QM and RN perpendicular to XY plane. So draw PL, RN, QM perpendicular to XY plane. Clearly we can observe PL is parallel to QM and it is also parallel to RN. And foot of these lie on XY plane. So therefore, the points L, M and N lie on intersection of the plane containing PL, RN and QM with XY plane. Now, so this is what the explanation. So I have taken PQ and I have taken R which divides the ratio in the m:n. Draw PL, RN and QM perpendicular to XY plane. So if these are all perpendicular to XY plane, then clearly we can say all PL, RN and QN are parallel to each other. And the point L, N, M clearly lie on the intersection plane where the line PL, RN, QM also are on the XY plane. So next, after this, draw a line ST through R parallel to LM. So I am writing this line ST parallel to LM. So next, extend PL to meet S and ST intersects line QM at T. So these are the observations from the diagram. We are going to draw a line through R, ST which is parallel to LM. Since we have only PL, extend this PL to meet S and this ST will meet this line at the T. So after all these construction, we can observe this portion, that is ST, this portion ST, L, M and here we have R and N. So all these are a quadrilateral and it is a parallelogram. Since opposite sides are parallel to each other, they are of the parallelogram form. So therefore, L, N, R, S and N, M, T, R are parallelograms. Let's see the triangles now. Let's see this triangle now. This one and this one. So now triangles PSR and QTR are similar. So when two triangles are similar, we can write their sides in the proportions. So therefore what we can write here, so we have written this in the form of M and N. So write it in the form of M by N. So therefore I will write this as PR divided by QR, which is nothing but M by N. This length PR can also be written in the form of SP divided by QT. Because we know when two triangles are similar, the corresponding sides will be of the same proportion. So therefore, I can write PR by QR as SP by QT. Now, listen here, SP can be written as LS minus PL. So, SP can be written as SL minus PL and QT can be written as QN minus TM. Next, SL minus PL can also be written as, instead of SL, I'll take NR minus PL. And you can write QM, that is QM minus NR. Why? Because SL and TM, this line SL, TM and NR all have the same length. So therefore, instead of SL, I am writing NR. Instead of TM, I am writing NR because I know the coordinates of this NR as Z2 and this as Z1 and this as Z3. So therefore, what I can write here, NR can be written as Z minus Z1 divided by Z2 minus Z. That is M by N. So we have the coordinates for P as x1, y1, z1. For R we have x, y, z. For Q we have x2, y2, z2. So the perpendicular length means it is exactly the z coordinate. So therefore NR is nothing but z here. Next we have PL. So this length PL is nothing but z1. And QM is or TM is nothing but Z2. I have just replaced the Z coordinate. Now cross multiply these two. What happens? It will become MZ2 minus MZ is equal to NZ minus NZ1. Shift MZ this side, NZ1 this side. So this becomes MZ2 plus NZ1 is equal to MZ plus NZ. Take Z as a common factor here. M plus N into Z. So, MZ2 plus NZ1. Now, if I need only Z, it is clearly MZ2 plus NZ1 divided by M plus N. So, this is a formula to find the coordinate of Z. So, similarly, we can write the coordinates of x is equal to mx2 plus nx1 divided by m plus n and y as my2 plus ny1 divided by m plus n. So thus writing all the coordinates here are x comma y comma z can be written as mx2 plus nx1 by m plus 1 n, my2 plus ny1 divided by m plus n, mz2 plus nz1 divided by m plus n. So this is how we can write the coordinate of a point which is dividing the line segment in the ratio m is to n in 3-dimensional axis. So this is the case where you have written in only 2-dimensional, one extra axis for Z. Now suppose other than this, we have proved the formula only for internal condition. Suppose what happens if a point externally divides the ratio? That sign changes. So this is the formula where we can write, that is for any point p x comma y comma z, we can write it as mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n, mz2 minus ny1 z1 by m minus n. So this is for external ratio. Suppose it divides equally. We have a point which is exactly dividing the line in the midpoint. Then the ratio will become 1:1. So in that case, so we have P is the midpoint of the line AB. So the midpoint formula is in the form of x2 plus x1 by 2, y2 plus y1 by 2, z2 plus z1 by 2. So in this formula, write m and n values of 1 and 1. So you will get x2 plus x1 by 1 plus 1 is 2. So similarly, we will get y2 plus y1 by 2, z2 plus z1 by 2. Whenever we don't know the ratio, but we have to find the coordinates, what shall we do using the formula? We have to write the formula by using k is equal to m by n. The same formula is used. Instead of m and n, we will write k here. So therefore, the point P can be written as k x2 plus x1 by k plus 1, k y2 plus y1 by k plus 1, k z2 plus z1 by k plus 1. Here, later, after finding the value of k, the value is replaced by m and n, and we can find the ratio. So these are the special cases of the internal ratio dividing the line. So this is the external ratio, this is the midpoint formula, and this is whenever you have to find the ratio in the form of k is to 1. So in this section, we have learnt the coordinate planes in three-dimensional geometry, how to write any point on x-axis or in any plane, and also the octants which divided into 8 parts, and 2 important derivation, distance formula and section formula. So very important for 5 marks, the derivations. We'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.